Once we saw how to configure Modbus protocol, we can show how you can configure Modbus SunSpec protocol. We will go through the following steps. Step 1. Adding the SunSpec Modbus component to the model. Step 2. Define the SunSpec models. Step 3. Configuring the registers. Step 4. Connecting the signals. Step 5. Compiling the model and starting the simulation. And Step 6. Reading the simulation values using external application.
First, we will delete the Modbus component and choose Modbus SunSpec component from the communication Modbus SunSpec Modbus device. If we double click the component, we'll get much more bigger dialog window where we can easily specify all the models. So basically, for the network configuration, we have the same configuration as in Modbus: IP address, net mask, and port. And we can specify the base register address of the registry map. These values, 40,001, 50,001, and 1, are defined by SunSpec and are fixed. We will use the preferred address 40,001. Also, SunSpec defines four models for each register map: common model, standard model, vendor model, and then model. Common model is the model that defines the basic manufacturer information for the device. So for example, we have who is the manufacturer, what is the model, options for that device, version, serial number or device address. For the ease of use, we implemented all those models at the click of the button. To add a standard model, just click plus and you can choose between all the models that are defined. For the example, we will use model 113 inverter 3-phase float. Select the model, then click OK. The model will be parsed and all the registers will be defined in the table. Also, vendor models can be added to the model, also by clicking Add. But at this point, you can load your own model file and parse it in the dialog window. The end model indicates the end of register map, and it's also fixed as is common model. First, we will set up the common model registers. Let's see how the table looks. We have a register field with register address, register size, name, label, value, type, read-write type, and description. These values are all defined by SunSpec. Because not all the registers are mandatory, some are optional, which register will be included and which will be omitted. And model controlled lets you control the value of the registers through simulation. Basically, that means if you click on model controlled, the input terminal for that register will be created on the mask. First, let's set up the manufacturer, for example, Typhoon HIL. Second, we will set up the model, for example, HIL 604. We won't use options and version registers. We will put in serial number 1234556. Next, we will configure the standard model. Click on Standard Model tab and configure what registers will be included and what will be model controlled. For example, we have number of registers that are predefined. If we want to use phase voltages AB, BC, and CA, we will select these registers, and if we want to control these registers, we will select model control. Also, for example, let's say we want to control the phase current and power. for the register that we don't want to control, we can specify the default value, for example 100, and for the cabinet temperature let's put 30. Once we configured every register, we can click on OK. All the registers that are model controlled get their own input terminals that we can connect to signals from the model. We can connect signals like so. Once the model is configured, compile and load the model and start the simulation. The application that I'll be using to read the SunSpec registers is an application called SunSpec Dashboard, and this application can be downloaded from SunSpec official webpage. Once the model is loaded, we can start the simulation. Go to SunSpec Dashboard, click on Device and Open. This will present you the window where you specify the server IP address and server and interface type. We select the TCP, put in the IP address value, port value, and click OK. And you can see here, these are the values that we specified in the configuration. The inverter values will be red, and you can see all the register values. The values of the registers that we controlled, or that we put a constant of 1 and 2, and cabinet temperature is 30. Using the SunSpec Dashboard program, you can be certain that the device that you're reading is SunSpec compliant.